Okay, back from dinner. Yep, does it show? No comments. Okay, talking about symbols, thank you. Specifically now wires, so shielded wires, S-H-I-E-L-D, shielded wires. Shielded wires. You've had a little bit of experience with shielded wires, and shielded wires be a wire with something like that on it, or maybe there's a bundle of them, and it would look like this. A shielded wire, this is like a double shielded wire. The whole purpose of a shielded wire is to cut out radio interference. Let's say all airplanes I've ever worked on, mostly you're going to see them as, they're called P leads for magnetos, which you will fully be aware of in a few weeks from now. And so a magneto is an engine-driven device. It's like a little AC generator that has some coils in there and some breaker points, and so it makes AC current that goes through a step-up coil and comes out at about 18 to 20,000 volts. Now to turn it off, what you do is you ground out one part of the magneto. And so what they do is they use a P lead, it's called a P lead, is all it is, just a shielded wire that goes from the magneto, so magneto, M-A-G-N-E-T-O, magneto, they put the neato in the mags, magneto, so that grounds it at the key. So if it's grounded, it's off. But what happens is it's grounded over on this end, and so it has a run from the magneto through the firewall back to the key or a switch. And so it does have a lot of voltage going, so that's off. When it's on, it looks like that. And it's just basically this antenna, if you will, sticking out because there's no ground here. And so you get this high voltage. It's actually still running. It's not as high through this wire, but it's enough that I wouldn't want to touch it. It hurts running through here. And so that can create radio noise coming out of that wire. So what you do is you have on top of it that steel braiding, and that steel braiding is then grounded at this end, or sometimes the other end. I was just talking with Phil the other day. There's something about how you only want it grounded on one end, and to be honest with you, I always see it grounded on the magneto end. Let's be honest here. What do I see? And I believe it's not grounded on the other end, but it is at the magneto, which is kind of weird, but it doesn't matter. So it's grounded right there, and that then quiets down all this radio interference and keeps it in that shielding, and the radio interference goes to that shielding, finds its way to ground, and dissipates without making radio noise. So that is a shielded wires. And so it's important, as you saw, that you don't have this shielding that's on the outside is not part of the inside of the wire. That is completely separate. And you're going to see wires like this when we talk about ignition wires, spark plug wires. There's multiple layers of insulation and steel braiding and stuff. So that's shielded wires. Shielded wires, let me see, used to shield out radio noise, used to shield out radio. I don't know, maybe that's not the best way to say it because it's not shielding the radio noise, it's shielding noise from getting to your radios, the static and stuff. Outer braiding. Outer braiding is grounded. And insulated from the center conductor. Somebody's trying to call you? There's somebody's phone going off like crazy over there. Is that you, Harry?
It is. Not anymore.
So, yeah.
I was just going to ask, the wire that had all those crisscrosses on it, that was the one that was braided?
It's a shielded wire with the braiding on top of it.
Okay.
Yeah.
Can you go back for a second?
Oh, you hate me. It was way back.
That make you find it all now?
There, found it. Good, I'll tell you this story. So, when I believe you're in that classroom down there, the rule is if your phone makes a sound, you get assigned a special project, a special presentation. So Larry's pretty cool. He'll pick something like, I remember had one of the students worked right over here at Helimax Helicopters, and so he said, all right, tomorrow I want a report on the CH-47 helicopters. And the guy came up and the class loved it. It was a really good report, all kinds of stuff. So
People probably got a cell phone number, started calling him in class.
that was where I was going with it. So yeah, people, they all have each other's cell phones. So they start calling, so they're spending all this time calling each other, trying to figure out whose cell phones are. All right, can I move now?
Yes.
Okay. All right, so then I have B, resistors. Well, you've already been working with resistors, so we have different kinds. We have the fixed, which you know is the squiggly line. We have adjustable.
Is there supposed to be like a certain amount of squiggles per resistor?
I've often wondered that. Is it like a, yeah, I thought there should be conventions, probably like 4, I think. So I think I actually got it right. I don't know for a fact. I got so much information around here. I don't know how much I want to, I'll just go with it. So adjustable. So I know this was a little confusing at first for you, but we have rheostat versus a potentiometer. So, trying to make it simple, a rheostat is simply a variable resistor, used to control the power load, used to control power to a load. Move down a little bit. So rheostat is used to control to a load. What else do I got? Rheostat, simple variable resistor used to control load. The correct term for the common terminal of the potentiometer is this. No, that's potentiometer. Let's do this. Potentiometer. Potentiometer uses 3 terminals. And the potentiometer is going to look like this, with the arrow. So what's that representing is a 3-terminal item, 2, 3, and that thing right there, the arrow, is called a slider. The common terminal is called a slider. That is also what you call a hamburger in the Navy. Only the slider and one other terminal are used. That is actually not correct. Hang on. I don't like this. All right, I'll scratch that. Let's get rid of it real quick before you write it.
Okay.
Too late.
It is called a slider. But as I'm writing, I'm like, God, I've seen it. It's wrong. I will tell you. All right, let me tell you what I wrote here. So rheostat's simply a variable resistance used to control power load. True. The correct term for the common terminal, why I started talking about a potentiometer is a slider, only the slider in one of the terminal used. That is under a rheostat. But a potentiometer uses all three terminals, That is correct. Enabling the variable voltage or signal to be tapped from the slider. So that's what I should have said. Allowing a variable voltage to be tapped from the slider. That's correct. To be tapped from the slider. And I did find this note, and I wrote it in here because I thought it was interesting, because it gets a little confusing. And so I thought this kind of summed it up. Potentiometers and rheostats are made the same way. But rheostats are usually beefier. And that's a quote, are usually much, and I even put it in quotes, meaning I found it on a source, beefier, as they are generally used in high power situations. In high power situations.
Kevin,
Yeah.
is there a difference between using slider and wiper?
No.
No?
I think I've heard it both ways.
Okay.
You just got to pick something and go with it.
Okay.
They're usually much beefier as they are generally used in high power situations.
That wasn't a chair. Too much personality.
Oops, let me write this. Installed in series with the load. So in other words, if I wanted to control some, let's say I have some lights, cockpit lights, and so I want to control those cockpit lights. So I have a little switch, and I'm going to put a variable resistor, a rheostat, potentiometer in series with the light, so that I'm controlling the amount of current flow to the light. So if I increase the resistance here, the light's going to dim. It would not work if I put it in parallel. So it's got to be in series. So what happens if your rheostat or potentiometer fails? Yeah, or I could draw it like this. So that represents a tap right there. So move it that way, be more resistance, that way less resistance. Draw it like that. All right. Circuit protection. Circuit protection. All right. So what do we have here? Yikes. 1, fuse.
So is it, sorry, like going back to the potentiometers and rheostats, is that, what else would they be used for? Just, I mean, I get it's a variable resistance thing to adjust current, so I guess pretty much anything, like motor speed or something like that.
Would they do motor speed? Got to be careful because motors draw a lot of current. But yeah, I think I have seen a motor speed.
Just, okay, but, alright, think about that.
Dual it.
Yeah.
What do you say, Harry?
Like a lawnmower?
Yeah, I guess. Yeah, the current thing is a big deal.
Yeah.
Don't they use potentiometers in like your fan speed adjuster in your car?
Yeah, it's kind of the same thing.
Yeah.
Yeah, I've taken those apart and played with them. You said fan speed in a car, the same thing. Yeah, it's kind of that way. It's just a switch that goes from different size resistors. Some of the resistors are quite large because you're actually pulling a lot of current out of it. They get actually kind of hot back there. Trying to think of what is in airplanes. Usually you have a round, and it really does look just like the potentiometer with the slider and wiper. It's a resistor that's actually round, and you just kind of wipes across it, changes resistance. Same thing with fuel gauges, believe it or not, are that way. So it's just a variable resistor. As the float goes up and down the fuel, it changes the resistance that sends a signal over, drops the voltage on the fuel gauge, which sounds crazy to have a resistor arcing back and forth in the fuel, but what's that?
The fuel gauge, the needle runs on electricity?
Mm-hmm. Yep.
Wow.
That sounds crazy, but it does.
Unless you got the 140, the corks and the wings.
Yeah, those are my favorite. Actually, I like the one is the older Ronkas is a cork with a corkscrew thing. So as the cork slides up and down in the fuel, it actually twists something like a corkscrew, and then that runs a gear that runs in a needle. I think that's kind of cool.
That's how it was on like a quad that I worked on.
Okay, yeah.
Very similar.
All right, circuit protection. Well, we got fuses. Fuses. Fuses are placed. Are they series or parallel?
Series.
Yep. In series. What's the problem with, well, fuses are expendable.
For one-time use?
Yeah, one-time use. No, actually, you can use them over and over and over again for a very long period of time until you blow it, and then you can't. The thing about fuses that I don't like, if you have an airplane that needs fuses, you have to carry spares. That's one of your Q&A questions. How many spares do you need?
A lot.
3 of each type? Yeah.
I'm not quick with you.
Or a roll of tinfoil. Whoa. The capacity of a fuse is rated in what? Amps. See who's been reading their Q&As. Then there is the current limiter. I don't want to write all this, but I like the way I wrote my notes here because it's lengthy. A current limiter, such as used in the armature circuit of a high current DC generator, is a form of a slow blow fuse that will accept a surge of current greater than the generator rating. But if there is a continual flow of current in excess of the generator rating, it will open the armature circuit and remove the generator from the system. So a current limiter is like a slow blow fuse. And I actually think blow in that case is BLO, but slow blow fuse. I don't know if you've seen a little chart in my office on the bookcase right there, but it's got the mechanic's guide to fuses. I don't think I put it in
That's a
here.
good one.
No, I didn't. It's got things like a bolt and stuff. All right, slow blow fuse. Cannot be replaced in flight. That is a mechanic thing. They're usually not located in the cockpit. They're like forward of the firewall. It's a maintenance item.
Can you replace fuses while on plane?
Yep, and you're supposed to be able to. So FAR 91, which is General Operating Flight Rules, tells you that you have to carry spare fuses. And they're right there next to you, so at your knee. So most aircraft have a little fuse holder. Fuses are easy to get to by the pilot. And then my 150 had fuses, and my partner hated them. I don't blame him. And so he put in circuit breakers.
Is there a picture for the current limiter?
No, it's just a wire.
Is it?
Yeah, the ones I've seen, it's like suddenly there's this fat wire with rubber coating on it. I'm like, what is that about? About that long? Sometimes a little squiggly. Yeah. So cars all have them. Yeah.
Replacing fuses, circuit breakers, especially some of the paperwork, is there anything else that's be done to the circuit?
Well, you got to give me a bad time. Yeah. So to replace the fuses with circuit breakers, does that sound like something I could just do on a whim?
No, it sounds like a major alteration.
Sounds like a major alteration, doesn't it?
Yeah.
So, as an IA, if I have approved data, I can approve it. So, now I'm incriminating myself on tape now. There might be an STC out there to do it, but the thing is, it's like the year before ours. Or ours had fuses, and like the next year they went to circuit breakers. So we used all the data from that one as approved data to do it on ours, and then so I created this very large, thick thing and made it into a whole packet and stuff, and then got all the data and then approved it with that. But no, it's no other work as needs to be done. What does it matter if you had a wire coming up to a 5 amp fuse and you just put in a 5 amp circuit breaker? It's the same, because all you're doing you're protecting the wires. Okay, so talk about circuit breakers, which all modern planes now have. So I know in your Q&As you do have references to quite a few FARs, but you have to get used to it because that's what we do. So FAR 23.135.1357 C1, last I looked, requires that circuit breakers not be automatically reset. So the resetting has to be done manually. So in other words, you're flying along, you're the pilot, circuit breaker pops. You don't want that to automatically reset all on its own, because the pilot needs to be the one to make that determination. So I know if I'm flying along and it's VFR day, and everybody knows what VFR is, right? It's the opposite of IFR. So VFR, visual flight rules, clear day, looking out the window, supposed to be. And I've got maybe my nav lights on, and I hear a pop, and I look down and I see my nav light breaker popped out. Well, I'm probably not going to reset it. That thing popped. It's VFR day. I don't need my nav lights. I'm going to leave it alone. I'll land. When I get home, I'll take a look and see why did that pop, rather than trying to keep resetting it and maybe start a fire somewhere. Yeah.
I didn't take it where isn't it by the book that you can reset it once and then it pops again and the other one?
I know that's something somewhere. I don't think it's a law.
I don't know about the law, but it's in the manual somewhere.
I know it's in a manual somewhere, because I definitely heard that before, that you don't want to reset it more than once. I think that's being kind of foolish myself. You keep resetting it.
Hold it in there.
Hold it in.
Yeah. Which, by the way, I don't think I wrote it in here, but I believe, and I can't remember the name of it, but there's a certain type of a breaker where you can actually literally hold it in, keep it from popping. You're not supposed to have that type on an aircraft, where you can hold it in and keep it. They're actually supposed to pop even if you're holding it. So resetting must be manual. They are placed in series, obviously, as close to the source as possible, right next to the bus. They do have resettable types. Oh, they are resettable. There is the, oops, we'll do this way, the 3 types. Three types. There's the push to reset. They're flush mounted. A lot of the ones in my airplane they're flush. You can't grab it and pop it. It will pop on its own and you can reset it. And then there is the push pull. Yeah.
If you had to pull part of the engine, you had to pull a breaker, how do you pull a breaker with a flush mount? Is there a special tool or?
You don't do it. You can't pull the breaker on a flush mount. That's the point of them.
Just hook it straight up to
Don't
the
like
battery
it.
and
Huh?
pop it.
So you're saying if I have to change the
If you have to change something on the engine, you need to pull the breaker so you don't set it off, start it, then how do you pull the breaker at all? So
You don't.
It makes it safe.
Switch.
turn off the master, unplug the battery.
And that's it?
Yeah. Yeah.
Can't have power, you lose the brake.
Not to mention, if you think about, I know you're thinking about ATI and big aircraft. My aircraft doesn't have electrical going to the engine except for the back of where the alternator is. We don't use electricity to run the engines. Okay, and then there is toggle type. The toggle type look exactly like a switch. Single pole, single throw, single pole, whatever, double throw. But on the very tip of the switch that goes up and down, there'll be a number stamped on it. A 5, a 10, a 15, and that's the amps. So you can use it like a switch / circuit breaker. And that's, a lot of people will do that with avionics master switches. You do that? Mine is. When I wired my plane up,
Newer planes do that.
yeah, my 150, when we wired the avionics in, we wired in with a master toggle, but my 182, I didn't. I went with just a master switch for avionics and then separate circuit breakers for all the different components. So, but those are the three different types.
Like the one in your house, basically?
Like the one in my house?
Like the ones that are on your wall in your house, basically?
Yeah, but those kind of slide back and forth, and they look like a circuit breaker. And these, you wouldn't know it. You just think it's a switch.
Oh.
So if it's installed in an airplane, you're like, well, that's just a switch. Where's the circuit breaker? But look real carefully. There's a number stamped on the end. Now you know that it's not.
So if it's a switch with a number on it, it's the toggle type.
It's, yep. I should say 3 types of operation. And then I hate it because it always does this. 3 different types. Oh, that's just 0.3. So it's different types. Different types. Now within that we have different mechanisms, I should say. So we have the magnetic type. So, and that's when excessive current flows through the circuit breaker, it's going to create a electromagnetic field that is then going to pop it. So, when excessive current flows in the circuit, it makes an electromagnetic strong enough to move a small armature which trips the breaker. That's a lot to write. So I just write trips. We don't need to know that. I'm just going to make it simple. So the magnetic type. Thermal overload. Thermal, T-H-E-R-M, thermal with an L. Thermal overload consists of a bimetallic strip. When it becomes overheated from excessive current, bends away from the catch on the switch lever, and permits the switch to open. Oh, dang it, I have some bimetallic at home. This has been a great time for it. So bimetallic means 2 types of metals, and they're bonded together, and they have different expansion rates from heat. And so when you heat it, it's going to bend. It's going to bend. It's going to bend. And when it bends, that's what trips it. So when they get hot, the outer one's are going to expand more than the inner one. It does a curve and then pop. So because too much current creates the heat. The heat is what does it. Let's see. A trip-free. That's what you get, those vacation vouchers that are worthless. 3 trip to a trip-free CB circuit breaker will allow the circuit to be broken even if the pilot holds the button in. You don't, so that's a good thing. This is point 4. Circuit breakers are designed to protect the wire. The wire, not the component. Therefore, the circuit breaker must trip below the capacity of the wire. Circuit breaker must trip below the capacity of the wire. And then aircraft, I think I already said this, do not use resettable breakers or automatic. Resettable breakers. Yes.
So if you have a circuit breaker and it's supposed to go off once it's below the capacity of the wire, is there a certain number below capacity or is it a set number?
I'm going to show you. It's very exact. So your motor project, you're pulling about 4 or 5 amps on that motor. That is well past the capacity of your little alligator clip wires. Some of you guys are running your motors for quite a while, kind of looking at your ammeter, and I'm thinking, man, it's going to start smoking any second now. And it will. Those wires start getting hot, start smoking. Because you're using a 2 amp and a 5 amp circuit breaker, those wires are 1 amp or maybe 2. They're not made to handle that much amperage. So your circuit breakers really aren't appropriate for the wires that you're using. So the circuit breaker protects the what? Wire. Okay.
So it's designed to protect the wire, but in protecting of the wire, doesn't it like also on the other hand protect the component as well? But it's not designed to protect the component, right?
Right. It's because I was trying to think of a nice way to say it. The component's its component is automatically protected by the circuit breaker, but it's designed in such a way that the wire's appropriate for the component and then the circuit breaker's appropriate for the wire. And so it's all planned out. It's not like they just throw in this component and then go, well, we're going to use number 18 wire, and that's the, that there it is, and then the component gets all burnt and fries up because too much current. It just doesn't work that way. Yeah.
And wouldn't it be harder to replace all the wiring rather than just the component?
This is spoken like a true mechanic. It's too hard to replace all the damn wiring. Replace the component real easy. So one thing versus a whole bundle. She's right about that though.
Down through the wing. I need that over there.
All right, I gotta speed up a little bit here. So switches. So the pole is the movable blade. And the throw is the number of paths. On is forward or that's or up. So you don't wire things backwards in an aircraft. On, you flip it up. Off, you flip it down. Or if it's overhead, forward, back. Or on the side, forward, back. It does not count if you put it in backwards and then label it correctly. Almost killed a guy doing that. Wasn't a switch, but it was a trim cable in a PA-12 Super Cub. And it's fabric covered, and it has a trim that goes around to this little wheel in the back and this little 1/8-inch cable. And so, 16th. And then you have to reach your hand up in this little hole, and you just kind of feel it and you wire it. And so somebody spent way too long trying to reach up there and run it around this spool and get it all engaged. And so he gave up, said, Kevin, it's your turn. So I said, okay. And so, you know, you're laying on the ground, you got your hand up there, you can't see a thing, but you're feeling it. I got it all wound up. I said, give it a shot. And he ran it. Gosh, oh man, I got it backwards. I need to undo it and redo it. You know, it won't take me that long. But then the senior mechanic said, well, what's the problem? I said, well, I can do it. It's not a problem. You know, it's taking me a couple more minutes to undo it and then redo it the other way. But I'm doing it by feel, and I just got it backwards. And so let me just do it right. He says, no, it's all right. I'll take care of it. You know, I'm just going to placard it. So he placarded it. I was so new and not even a pilot at that point. Now, looking back at it, just makes me weak in the knees. But so he did. He placarded the trim wheel. Now, trim, this is, when you fly along, this is nose down, right? That's intuitive. And this is nose up. And so the pilot took off, and I forget which way it was, but he's like, let's say he's pulling back really hard because the thing just wants to do this. So he's like, man, I need to put a little nose down trim. Made it worse. Now he could barely fly it. And of course, he didn't think that it's backwards. He's not going to look down. He's trying not to kill himself. And he comes back and he's white and shaking and like, oh my God, I can't control it. And it's like, I said, well, it's placarded that way and stuff. And, you can't do that. You kill somebody. I'm like, well, I can. So then the boss goes, all right, Kevin, rewire it. It's 5 minutes. I was done. It took longer to get the stupid P-touch out, make a label and stick it than it did to do it the right thing. So that's why you can't, to tell you that story, don't do something backwards and go, well, I'll just label it and somebody will notice. You don't as a pilot. And that's not something you generally think of when you're doing that. All right. All right, so we have single pole. We have pole. How many blades? One. Single pole. How many pass?
One.
Single throw. How many blades? Single pole. How many pass?
Two.
Double throw. Let's see. How many poles?
Two.
So double pole. How many throws?
One.
Single. There you go. All right, then you know this one then. And that little dash line means those two things move together, so you only have one switch, or one little blade. That is? Yeah. All right, good.
So it's a single throw because they're mechanically connected?
Sorry, it's the little dash line indicates that you are only going to see one thing to grab. You're not going to see two things. That's two separate switches.
Thank you. Can there be more than just two throws?
I'm sure they make all kinds.
14.
I don't know the word for 14. QP, quadruple pole. I don't know.
So some
More or
of the
less
switches,
than one day.
some of the switches for the motors, how they like you'll have an on one way, an off in the middle, and then
Yeah.
on the other way.
Yeah.
would that be considered another?
3-position.
Yeah.
I call it 3-position.
Okay.
Just add the position in there.
There
So
we go.
switches, and then of course you have momentary switches, which you have to hold to the on position, usually with a triangle. So there's all different types of ways that can go within those. Switches that are operated only in an emergency. Emergency or inadvertent, mean accidental. Inadvertent operation could endanger a system. They use a guarded switch. And a guarded switch looks like that. So it's got that little guard cover on there. So in order to use a switch, you lift up the guard, flip the switch forward. When you flip the switch back down, it knocks the switch back to its normal position. Can I move? Oh, you guys are killing me. All right, so I think we've already gone over batteries, single cell, multi-cell. You know what a ground is. Considered a zero reference point or zero voltage point. A return path, yes.
When you have a guarded switch in a schematic, is it drawn differently?
I don't know what it looks like as a schematic. Probably just labeled. Says I'm missing a page. Hope it wasn't important. There it is. All right, yes, we covered relays, solenoids, right? All right. I'll be sad if I don't do this.
Why is the ground considered zero voltage?
It's what they say. Let me think. I have a good reason for this. Somebody asked that before, and because you go back to conventional theory, and so if you go to conventional, not electron theory, ground is considered the safe spot because we use you call it a negative ground system, which is opposed to like an MG car, which used a positive ground where they hooked the negative side up and the negative side ran to all the components, and then the components then went down into the short wire ground. We call it ground, but it would go to the positive side of the chassis, and then the positive side of the battery had a jumper that would just go to the chassis. So that's what it used to be, but so we turn it around and we just call that the zero voltage point. That's probably not the best answer you want, but that's just what they call it. So yeah, consider the zero reference point or zero voltage point. It's a Q&A question, and that's the actual answer out of that. That also indicates a return path of current. Okay, we did talk about relays quite a bit. So we have a relay. So a small amount of current can drive a very large item. Yes, we did talk about this. Remember drawing all that. Let me see. Fixed core and movable linkage. We talked about that. Sometimes you may see something that says NO or NC. This is normally open. That means in its relaxed no voltage state, no power state, it is open. So what I've just drawn right here is a normally open solenoid or relay, because you can see that the switch is open and there's no power going to the relay, and it's just sitting there relaxed and open. Or I could have normally closed, which would be in its normal relaxed off state. It looks like that. And when you power it up, it'll open this. So anode NC.
You get relays that have both in one.
Yeah, of course. So it would look kind of like this. There. So this would be the, which one would be the NC or NO? NC, normally closed. Power's off, that's at rest. Well, that would be normally open. It would just be, yeah, sorry, normally open. So no power, this is open. No power, that is closed. Apply power, and it swaps over. Of course, it doesn't change the designators. It's still NO or NC. It's just you have power applied, and it's on the no. All right, I need to get some new paper here. Can I change it? Oh, it's break time.